So you are welcome to PHY207 class. Last week, we were able to look at the first topic, and I guess you must have gone through it as well. The instructional video is on the portal, so it is advised that everybody should check through the instructional video, so that by the time you come to class, it should just be you bringing up the gray areas where we look at together. We have a very short time, so I will like to share. Okay, please, can you drop your number? I want to send it. Okay, Michael Ibrahim, are you the one that created the? We have a WhatsApp group already for this page, right? 207.
I'm not in the group, sir, and I've tried to reach you. That day I was not able to save your number because of.
Okay, what you do is that I guess Adesai Amin is in the group. Adesai Amin, are you in the WhatsApp group?
I'm not in the WhatsApp group. I'm not in the WhatsApp group.
Someone joined us last week. I'm coming. Okay. So we'll focus on one other guy. Okay, what will happen is that drop your number. Everybody drop their number. I'll drop my number too. So someone should copy it. We harmonize the two groups later. So on the chat, when you drop your number there. Even the one we did the other time for the 203, I don't think the person asked to create the group, I don't think he did it. So I think when else we meet. So Michael Ibrahim, copy the 3 numbers, you can form the WhatsApp group as well. Copy the 3 numbers. Is that clear? Okay, good. So having done that, let me share the course material. Last week, we were able to check the first last week, we were able to share the first topic. Today, we'll be looking at a fresh topic. Look at a fresh topic. Can you see the material on display? What did we go through? What did we talk about last week? Can anybody tell me that?
For me, I did not participate the last topic you did. This is my first attendance for this particular course.
We talked about thermodynamic system.
Thermodynamics. We talked about the terminologies, the system, the surroundings. Then we have more different types of systems. So,
and isolated system.
Yes. So let me bring up the course material itself briefly. Good. So let me share it now. And let me bring up the slide itself. Okay. Let me just bring out the course material for those that have not gone through the material. So we treated a whole lot of the material. We've treated up to this stage. I think we stopped at zeroth law of thermodynamics. I guess we're on this page 19. And I said you should go and answer all these questions. So, who can tell me what we know about zeroth law of thermodynamics? I can remember that day I said everybody should write A, B, and C with A touching B and B touching C, A, B, C. And I stated that if system A is in thermal contact with system B, and also system B is in thermal contact with system C, that means A and C are in thermal equilibrium. That is what the zeroth law of thermodynamic states, and that this is what this one is talking about. System 1, system 2, they are in thermal contact. So if one of them is in thermal contact with another one, the other one and this first one, they are in thermal equilibrium. So today we'll be looking at, and I said you should go through all these equation, go through all this equation and come to the class with, we're going to start. I said we should also go through the differential calculus. It's meant for those that are deficient in calculus, because I'm not going to take it to the class. It's more of mathematics than the topic itself. So today I'll be starting from measurement of temperature. So let me stop sharing the material. So it is expected that you must have studied page 1 to 30 of this class, or of this of the course material before you come to class. So today we will be looking at measurement of temperature, and that one goes from 31 to 31 to let me see. (31 to 40 or 41), I can see 31 to 42 or thereabout. So we have about 12 pages for you to cover. You should have covered that before now, but let me just have a slide for that. Let me share the slide. Can you see the slide now?
Yes, we can see.
Okay, good. So I said measurement of temperature. So I said temperature can be defined as what? The degree of hotness or coldness of a body. And we said temperature of a body has no upper limit, but it has a lower limit, that is the absolute zero temperature. So temperature can range from any value. The lowest value might be is the absolute zero temperature, that is minus 273 Kelvin. Now, heat is different from temperature. Heat is a form of energy, and it is transferred from one part of a substance to another, or from one body to another by the virtue of temperature difference or difference in temperature. So don't ever mix temperature and if you say heat, and heat can also be defined as the amount of energy a body possesses. The amount of energy a body possesses. Now, that's what I just defined. It can also be defined as the amount of energy, internal energy a body possesses. Now, we said heat is positive when it flows into the system. For example, if we are boiling water, at that time, Q is positive. Now, but if you leave the water or a block, an ice block, what's happening in that regard is that it is flowing out of the system, so it's actually gaining energy. But if you leave a hot water, a boiling water, and left it for some time, it will start losing energy. So at that point of it losing energy, is Q will be negative. So now, having said that, the next slide. Now, I guess this one talks about what I was trying to describe last some few minutes ago. I said, if bodies A and B are in thermal contact, even if you are holding somebody, even as individuals, if you are holding somebody, if you discover at a time, you must have discovered that if you are holding somebody, say, this person's body is hot.
Yes, sir.
Hello.
The slide is not moving again.
It's not what?
It's not moving. We only see the last week tutor mark assessment.
No, I'm displaying the slide. Zeroth law of thermodynamics. That's what should be on the slide.
The slide is not okay. It's not moving. It's
Yes.
not moving.
That's what he's talking about. That's what is on the screen. You have to check it yourself.
So this, I'm talking about the zeroth law of thermodynamics.
No, yeah.
Yes, that's it. Zero of thermodynamics.
Yes. I say if two bodies A and B are in thermal contact, there will be heat exchange provided they are not at the same temperature. And I'm using an illustration of two people holding each other. You must have held somebody before, say, your body is cold. Why? Or somebody saying, your body is hot. That means two of you are in thermal contact, but there's a form of heat exchange. And knowing fully well that the two of you are not having the same temperature. So, and we said if temperature is going into a system, it will be what? It will be what? Positive. But if the temperature is reducing or heat is reducing, it's giving out energy, it will be negative. And we said, what to now define zeroth law of thermodynamics? We said if A and B are in thermal contact, there will be heat exchange provided they are not at the same temperature. This continues until the two bodies attain the same temperature. Then it is said to be in thermal equilibrium. Now, I want you to note the terminologies used here. One, we said thermal contact. Then we said thermal equilibrium. Two, now, assume that one of the two bodies, now, do you have a biro there?
Yes, sir.
If you have your biro
Yes.
there, write A, B, and C with their bodies touching each other. That was the illustration I gave last week. Write it on your paper, A, B, and C. Let them touch each other. Let the side of A be touching B, and let the front of B be touching C. Have you done that? Have you done that? Have you done that?
Sir.
Hello?
Yes, we are with you. I've done it.
Okay, now you can see that what we're trying to describe is that look at A and B. They are in thermal contact. Is that also? They are in contact with each other. They are touching each other. So we are taking A, B, and C to be three systems. Now, if A and B are touching each other, we can say that they are in thermal contact. So if A's temperature is higher than that of B, there will be a form of heat transfer from A to B. Is that also? Until they are they have the same temperature. That's what we call thermal equilibrium. But also look at B and C. They are in thermal contact. Is that also?
Yes, sir.
And they're not of the same temperature. Now, a time will come that they will be in thermal equilibrium. Is that also? We are not saying that A that is not in thermal contact with C, there will be a time that the three of them will be in thermal equilibrium, or A and C will also be in thermal equilibrium. Do you get that now?
Yes, sir.
A and B are in thermal contact. A time will come, they will reach thermal equilibrium. B and C are in thermal contact, that there will be a time that will be in thermal equilibrium. We will now say that A and C that are not touching each other, there will be a time that they will be in thermal equilibrium, but they are not in thermal contact. Please note that. So that is what zeroth law of thermodynamics is talking. That's just the basic concept behind zeroth law of thermodynamics. Now, we have different scales where we, what's it called? we measure temperature. And there is a particular definition that is of utmost importance to everybody. Now look at it. Triple point of water. If you are told to define triple point of water, it can be defined as the temperature at which, not these three words, the key words here, solid ice, liquid water, and water vapor coexist in thermal equilibrium at the same temperature and pressure. Please note that. So if you are trying to define triple point of water, this is the temperature at which solid ice, or what we call ice block, liquid water, normal water, and water vapor coexist in what? In thermal equilibrium at the same temperature and pressure. And this triple point, the temperature, triple point temperature is given as 273.16 Kelvin. And this value is a standard fixed point for the calibration of thermometers. Other fixed point temperatures besides T3 are boiling point of water, which is at 100 degrees C, and absolute zero temperature, that is minus 273 Kelvin. So the boiling point of water is 100 degrees C, while the absolute zero temperature is 273 Kelvin. It's not 0 Kelvin, or is a point all gases have zero volume. So in the next slide, I have a summary of different temperature scales. Now, if you have this with you, you will discover that if you want to convert from Fahrenheit, this is TF, T subscript F. So if you have a temperature in Fahrenheit, so if you have 270 Fahrenheit, you can convert it to Celsius. So which would be, let's say the temperature in Fahrenheit is 232. So it will be 232 minus 32. That's 200 multiplied by 5. That's 100 divided by 9. 200 times 5, 1000 divided by 9. That's 111 degrees Celsius. And you can do it the other way around too, from Celsius to Fahrenheit, and from Celsius to Kelvin. So if you have any temperature in Celsius, let's assume I have 30 degrees Celsius, is equivalent to 300.15 Kelvin. Is that clear?
Yes, sir.
And you can also do the reverse as well. And mind you, you can also calibrate your thermometer. If you are trying to combine 2 or 3 thermometers together, for example, you can be given the upper fixed point of a thermometer that coincides with the boiling point of water or of a Celsius scale, which is 100, and the one that relates to the zeroth. Then they can tell you to find the temperature of that thermometer at a given or known temperature. I guess as we proceed, by the time you read through what I said you should read, you should be able to solve some questions on that. So now, having said that, now look at the next slide. Now, thermometer was named after the thermometric property used for the construction. So any physical property that changes measurably with temperature is called its thermometric property. Now, note that what is the thermometric property of a thermometer? It is any physical property that changes measurably with its temperature. Now, we have a thermocouple thermometer. The thermometric property is the EMF generated when 2 junctions made from 2 different metals are maintained at different temperature. That is its thermometric property. Now, the resistor thermometer, the thermometric property is the electrical resistance of a conductor due to a thermal excitation. The third one is constant volume gas thermometer. The working principle is based on the pressure of a gas in a given volume. Then the fourth one there is the thermobimetallic strip, or what we call a liquid in glass thermometer. So the thermometric property is what is volume expansion of a solid. So that is all I have for you as per a summary of that aspect of the note. So I will share this and go through the course material. So if you have any question, you can bring it up. Let me bring up the course material itself. Unit 3. So let's look at the summary, the conclusion we have here. We have talked about the zeroth law. Can you see?
Yes, sir.
So it's named after its properties. That's what I explained earlier. And look at the summary of the page. The heat is a form of energy that flows from one point of the energy of the system to another. While temperature is the degree of hotness of the coolness of the body. So thermal equilibrium is reached when system in contact directly or indirectly attain the same temperature. That is talking about zeroth law. And we said thermometric properties are the physical properties of material that changes linearly with temperature, and these properties are used for the construction of the thermometer. So can you see that I've been able to summarize all what you have here. Now, look at a critical example of a constant volume gas thermometer. Here's an example. What is the thermometric property of a constant volume gas thermometer? What is the thermometric property? What is the thermometric property?
Yes,
I think
I'm hearing you. How far?
Yeah, can you hear me?
He's back. He's back. He's back. He's back. Yes, sir. We can hear you. Yes, sir.
Okay. You can see that we've gone through the course material.
yeah, I think he's back.
Can you hear me?
Yes,
Yes,
sir.
sir. Yeah.
So I think I had a network of failure. So you can see. So you can actually go through all these examples here, go through the course material, and if you have a what's it called? You can see all these properties, the thermocouple, the four temperature I made, the thermometric properties, the four type of thermometers. They are the ones you have to go through it. Now you can see. You can see here that I said they said explain what is meant by the triple point of water and state zeroth law of thermodynamics. Those two are very important. If you don't know anything in this course, you must know that. And read up calibration as well. Calibration is very important. For any temperature scale, it must be calibrated. Now, I'm trying to look at okay, I think for lesson 3 here, the intended learning outcome is explain the concept of heat and temperature. We've achieved that. We have explained the zeroth law of thermodynamics. We've done that. We have defined thermometric property and mentioned different type of thermometer. And I've mentioned 4. Do you have the 4? or I should just call it for you again. You have the thermocouple thermometer. And we said the thermometric properties.
That mercury in the course material in the material.
Yes.
I need the fourth one. What's the fourth one, sir?
This is the resistance. We have the thermocouple thermometer, the resistance thermometer, the constant volume gas thermometer, and the bimetallic strip or liquid in glass thermometer. So they are well illustrated in the course material. Just read it up and practice one or two examples in the course material. So the intended learning outcome, from what I can see in the course material, let me go to the course material again. This is the course material. Do some calculations on temperature scales. I guess that's the only thing we have not touched on the, let's look at one or two questions. If we can find any. Jacob Tosin, you are welcome. Where are you joining us from? Jacob Tosin Samuel.
Yes, sir. Good afternoon. Okay, good evening, sir. From Kaduna, sir.
Okay. We had our class, I guess this should be the second or third week, if I'm not mistaken. So what you do is that we have covered a lot. So the implication is that you have to go through the course material, and I think on your own as individuals, what you should do is that you should go through the course material and get back to me probably next week, so that by the time the network, somebody is trying to call my number and I don't know how to actually stop that. So I guess we've gone through the course material. So if you have any question, this is a good time to ask questions. Do you have any question? So Jacob Tosin, what you do is that you can drop your phone number on the chat section. I guess Michael Ibrahim will create the WhatsApp group for us, right?
Yes.
So Jacob Tosin, go through the chat menu, drop your number so that Michael Ibrahim can copy your number and form. He will join you. We add you to the WhatsApp group so that
I was available last class. I think I was there. You said Miriam should do that.
But the Miriam is not in class now. So what you do is
Okay.
I think what you will do now is that you have access to the group, right?
Yes, sir.
Good. Now, go. Can you see our chat?
Yes, I can see.
So what you do is that you can help us copy these numbers and add the three of them, the two of them to the group. I guess I'm there already. But since
okay.
So can you copy the one for Michael? Michael's number is 007 819 9259.
080. Sorry.
78.
Okay.
19.
Okay, sir.
92.
Okay.
59. Or who was that?
Adisa
Amin.
Yes.
That's what Adisa Amin. So for Michael Ibrahim now, his number is.
That's my number. You call now.
Can you hear me?
Okay, I'll drop it on the chat for you.
You said what?
I think Mr. Jacob said I should drop it in the chat. I will chat.
The line is breaking. Hello?
Okay. Can you hear me? Do you have the other number, the Michael's number? Let me give you the other number now. 070.
You can also check the chat. I've just dropped my number now.
Yes, just check the chat. Jacob Tosin, Samuel, just check the site. Just check the chat. You see the numbers there. Is that clear?
The line is extremely breaking. I don't know what's happening.
Can you see just check the chat. You see the number.
Okay, sir.
You
Okay,
see
sir.
all
Okay,
the
sir.
two numbers for them. Just copy it and add them to the
To the group.
yes.
Okay, sir.
If you are not an admin, just put add, so they will add the two of them.
Okay, sir. Okay, sir.
So I guess what you should do now is that everybody should read ahead of the class. So next week we'll be talking about heat transfer mechanism. So, and I guess you all must have gotten yourself acquainted with the matter. And you should as well check for past questions so that you practice ahead of. When is your TMA starting?
We've not been advised.
Okay, so you can see heat energy, method of heat transfer. We have the conduction, convection, and radiation. So I will not dwell much on conduction, convection, and radiation. Where I will dwell more is the on 3.5.1, absorption and emission of radiant energy. And I will dwell more on Stefan Boltzmann law of radiation and 3.6 Newton's law of cooling. So the implication is that you should read ahead of the class, and before you know it, you would have gotten yourself acquainted with the course material. So any question from your hand? Any question? So you are meant to read up to page 52. So by the time we meet, we'll just talk more on. Now, if time permits next week, we might look at some other. I guess the course material is voluminous. Let me see. I'm trying to go through the course material and see and have you checked the instructional video? Have you tried to check the instructional video on the?
Yes, I'm checking.
All the videos are there. So if there's anything that you don't seem to understand, you can always go back to the video, watch it over and over again, and before you know it, you are good. I guess from your hand, you can even download it. You should be able to download. I'm going through the course material. I guess I'm trying to see, because I've covered a lot. Okay, entropy. I think I've covered entropy. I'm looking at the slides I've made for the class. So I'm going through the material, the second law, Carnot engine. Okay, I think I've covered all this. I'm saying probably we should merge two together so that we can hit engines. Okay, I covered this one as well. I've covered all of this. Let me see. Although some of it, you are the one that will go and read up. Because it is even easier to read. What you do, the way to read this kind of material, let me teach you how to read it. What you do is that you jot down. As you are reading, you write down. So you have a summary. Because if you read, for example, if you read the whole of this material, you should have, let's say, a summary of, let's say, this is 164 pages. You should have maybe 80 pages as summary. You should have 80 pages as summary. I've covered all this, so you are still safe. I've covered all this in my material to be used. Okay, I guess I've covered all. Although there are some part of it that you are the one that will go and read on. And you know, this is a facilitation class, not the normal lectures that you come and you are to be explained to. My duty here is just to come to class and explain, or you point out the gray areas that you have in the course, and I throw light to it. Throw more light to it. So basically, so if you have any questions regarding what we have treated so far, do you have any question? Do you have any question? Even if it is that of last week.
No.
So if you don't have any question,
Not at all, sir.
if you have any question,
No, not at
I'd like to ask a question. What is a system?